welcome back to Mind and Maths. This is a very short lesson which is a continuation of differential equations part 1, where I left the lecture where by not giving an explanation for why the homogeneous solution for complex roots is written like this. So I'm just going to go ahead now and show that proof. So remember, this was the homogeneous system. We tried this trial solution, and when we got the characteristic equation, it basically had two roots which were distinct but also complex, and we wrote them like this. So how did we get that answer? Okay, first of all, just recall that we said any complex number of the form a plus id can be written as r e I theta plus r cos theta plus, oh sorry, this was inequality, I sine theta. So we've already covered this in I believe the lecture 1 on difference equations. Okay, so remember, since we have distinct roots, we can write the homogeneous solution as C e lambda 1 t plus d e lambda 2 t. So continuing this, we can put in the values of lambda 1 and lambda 2. So lambda 1 was h plus I v t, and lambda 2 was the complex number h minus I v t. Okay, since this is remember, we have this rule: if we have exy, we can write it as ex plus y, we can write it as ex ey. Okay, so I'm just applying the same rule here. We can write this as eht eivt, and over here we can write this as eht e minus I v t. We can take EHT out as common, and then we're left with a C E I V T plus D E minus I V T. So I can use this fact here. So I can convert this into the oscillatory functions cos and sine. So the value of theta is basically Vt in here. So writing that down, I'm going to have a C into cos Vt plus I sine Vt plus D cos Vt minus, actually plus I sine minus Vt. Okay, actually I don't want to skip a step, so let's just write okay, remember that for cos, a cos minus theta is the same as cos theta, whereas a sine minus theta is a minus sine theta. Therefore, we can write this as, I'm glad I didn't skip that step because it could have been confusing for some people. So we have a cos Vt and then we have a minus I sine Vt. Okay, so now I'm going to take cos Vt as common, and sine Vt as common. So then I'm left with Vht, bracket open, C plus D goes with cos Vt, and C minus D goes with a sine Vt. So basically, we took this constant as an E, and we took the other constant, other number, as an F. So this is how we arrived at this conclusion. So you don't need to show all of these steps. When you do get complex roots, you can simply jump to the answer here for the homogeneous solution. I hope this was helpful, and inshallah see you next time. Take care.